So this is my first look at the sample test for sample test 5, which is really test 4 in the class. The first 3 problems really just ask, do you have a calculator that you know how to use the square root button on? First one, root 441 is a perfect square. If I put in square root 441, press enter, my calculator tells me the answer is 21. On this calculator, it's second, and then the x squared button, which is right there to bring up the root. On your calculator, it may be different. I promise if you put in your calculator to Google and ask where's the square root, it'll return an answer. If you really can't find it on your calculator, email me, send me a picture of the calculator, I'll see if it's there. But this is the one key that you absolutely need to do this test. So please make sure that you have a calculator that can do it, or email me if you're not sure if your calculator can. When I'm moving on and trying to do the root of 8, this isn't going to come out perfectly, but when I put it in, I get a decimal that I can round to 3 decimal places like it asks. So the decimal that's showing up on my calculator is 2.828427125. When it says round to 3 decimal places, that means it wants 3 numbers after the decimal point. Where we're cutting is then the 4th number on back. But before I cut them, I have to look at this number and say, is that number 5 or greater? In this case, it's not, so I can just cut this off. If this had been a 7, for instance, that would be 5 or greater, so I'd have to round up and call this 2.829. Since it's 4 or less, I can just say my final answer is 2.828. For number 3, I'm putting in 5 second root of 6, and it tells me 12.2474. Again, that 4 drops off, so it can just be 12.247. Number 4 introduces a variable. Remember that whenever we try and reduce this variable inside by the root, we consider what the root number is. If there is no number on the root, it's as if there were a 2 there. So we make that the bottom of the fraction, we make the power the top. So this would really be y to the 6 over 2, which would reduce to y to the 3rd. Here, I want to separately look at the root of the number and the root of the variable. The root of the number 25 is a perfect square. It would give me 5. When I take the root of the variable, it's like saying I have t to the 8th divided by 2 because it's a second root. So it becomes 5t to the 4th. For number 6 here, it's a 5th root. So when I rewrite the power on the variable, I take the power that's there, and now instead of dividing by 2, I divide by 5. That's how I get y to the 7th. For these problems that ask me to simplify, they're not going to work out perfectly. I don't want to get the decimal answer that my calculator would give me. These are the types of problems where I really have to look at that list of perfect squares and cubes, try and find the largest perfect square or cube that goes in depending upon what type of problem it is. Here, because it's the square root of 72, I'm going up my roots list. I'm going to start at 64, doesn't go in evenly, go up to 49, doesn't go in evenly, go up to 36, does go in evenly, it goes in twice. So that tells me this can be simplified to the root of 36 times the root of 2. Once I've got it broken down into a perfect square and a remainder, I just take the perfect square out, root of 36 is 6, and leave it multiplied by that remainder, in this case the root of 2. Similarly, when I'm working with a variable, I want to break it down into a part I can take outside of the root and a part that's going to be left behind. Since this is a square root, I can take the largest even number that's less than 4 or less than 15 and know that that root will work. So the largest even number less than 15 is 14. It leaves behind just 1x. I could put a first power there, but it's unnecessary. To do this x to the 14th under the understood second root, it's going to become x to the 14 divided by 2, and then still have a root x next to it. So the final answer would be x to the 7th, the root of x. Number 9 is very straightforward. Basically, I just need to remember these roots, as long as they line up, is the same root number, same number under the root. I add them as if they're a variable like x. So if this had said 5x plus 8x, I would have gotten 13x. It says 5 root 7 plus 8 root 7, so I get 13 root of 7.